folks, welcome back to the HS Tech Channel. In this video we're going to look at old PC LAN server protocols. So we're going to look at Samba, IPX, NetBIOS, SNA, and DECnet, and a few other odds and ends, and we're going to look at mixtures of those, and we're going to explore them working and running in the real world here. I'd like to preface this video by saying two things. One, these protocols are hideously obsolete. Do not expose these to any security critical system, because none of these protocols really have any real security. Second off, it's a well-known secret at this point that I don't actually sound like this. I'm talking through a voice changer, and I have since even my earliest videos. So if this sounds bad, let me know, because in reality I sound completely different from this. This is entirely a synthesized voice. Anyway, let's get started here. We're currently looking at Wireshark sitting on my retro network, if you will, which is just a standard 10 gigabit Ethernet LAN. Except I've got a bunch of old, obsolete systems sitting on it. If I stop the scrolling here, you'll see a lot of protocols that may look kind of odd to a lot of people, especially people who may be taking networking classes in their high school or university or as a hobbyist. You may recognize stuff like, oh, everyone knows TCP and UDP. Some people know IGMP, and well, everyone knows ARP. But what is RTMP? What's DECnet, STP, IPX, SAP? What are all these? IPX RIP? What's this 06002 thing or whatever? What is all this? LAT? Well, this is what I like to call what networking used to be like. Many eons ago, TCP/IP was not necessarily the dominant protocol on PC LANs. It was actually all of these other protocols. Specifically, IPX was the dominant protocol on a lot of PC LANs. And you may notice these bizarre addressing forms here. Like, what is this? 002.AAOO blah 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 blah. Well, that's because this right here is what we'd call the network address, and this is what we'd call the host address. This right here is a DECnet address. There's the network address, there's the host address. Of course, they call it the area number and then the node number. This right here, RTMP, this is for the AppleTalk protocol, which we're not going to really be covering in this. I'm going to see if I can do a dedicated video on AppleTalk. But there we go. There's the zone number, and then there's the node ID. And of course, a lot of these protocols have some commonalities, like the broadcast address for IPX is always all Fs. The reason for that is because that's actually the Ethernet address that the packets go to. Same thing with AppleTalk. Broadcast address, it's one that's considered a broadcast address, which is why we can see it on this machine here, because this is plugged into an Ethernet switch and this is not running in promiscuous mode. Here's a spanning tree packet. If you've studied anything regarding Cisco gear, you probably know what spanning tree is. It is used to detect switch loops and other such collision domain problems. IPX routing information protocol. This is not the same as IP RIP. This is a completely different protocol, but this right here is beaconing out some server with this address is spitting this out. And as a matter of fact, I happen to know offhand, this AA0040003204 is actually a Cisco router. However, this Ethernet address form here is very specific because the packet right under it actually uses these specific, these final two octets of the MAC address actually to encode the actual higher level address. So let's see what we've looked at so far. We've looked at about 5 different protocols and none of them made any sense. So we've looked at IPX, we've looked at DECnet, excuse me, we've looked at AppleTalk, we talked about spanning tree, we don't care about it. This right here is SNA, which is IBM's protocol. And there's all this other crazy random stuff. This right here is a router beaconing, Ethernet router rather than Ethernet end node. And then here's a SMB net logon packet, and this right here is actually coming from an OS2 machine. I happen to know the addresses off the top of my head. This right here, don't worry about that one. That's something else. Don't know how some of this is getting through. Here's a WHO packet. Wow, yeah, wouldn't it be great if there's just a protocol that just beacon the load of every server on your network? Well, with WHO, there is. Here's the browser protocol, which is used by Windows to beacon and announce hosts types, and we're going to look at this. But first, we're actually going to switch over to a virtual machine, and we're going to take a look at all of this running in the real world, so to speak. So I know normally I wouldn't use Windows XP for anything, because to me that's kind of new, but we're going to use Windows XP for this particular demonstration, because it's relatively easy to set up, I found. Now, right away, you're going to notice that this client looks a little bit different from what people are normally used to seeing. That's because this is actually when you install the NetWare client for a NetWare Network provided by Novell, you get the special client that you need. Now, Windows does have built-in network support, but I recommend not using it. It's kind of bad. So we're going to go ahead and sign in here with the password 123, of course. And there are actually two things that we're doing here. We're signing on to a Novell E directory, and we're also signing on to a Windows domain at the same time. Okay, so I know this is a little bit confusing, but you're going to get a lot of this. So nowadays, we all know Active Directory, right? So this machine's sitting on this Win2000 domain, Active Directory domain, but this machine's also sitting on this NetWare 5 Novell domain, or specifically Novell Directory Services. Active Directory is often seen as a clone of Novell Directory Services. It came out more or less about 5 years after NDS was a thing. So we're signing into a NetWare domain, and we're also signing into a Windows domain. And in all of this is just for the authentication stuff. And I'm going to click OK, but we're going to look actually at the Ethernet packets that blow by rather than the actual sign-on action, because it's not interesting and there's not much to see. So we're going to go ahead and click that, and right away you're going to see a lot of packets that may be kind of unusual. There's that NCP blowing by, and then there was a few other things, but it's my understanding that it's still logging in, and it's because it's doing multiple logins right now. It's got to log into 2 different domains, if you will. There we go, that's some IPv6 junk we don't care about. And eventually we'll be signed on. Okay, so I just heard the sign-on sound from the VM, so at this point we are signed on. And it is still doing its post-logon screen sign-on stuff. So I think that's good. We'll go ahead and scroll up. So it did just attempt to solicit a IP address from my IPv6 router, at least that's what we're going to call that. And then there's a few things that happened here. So for one, it's going to start querying using Network Core Protocol. It's going to say, hey, I'm signed in. Now this right here is specifically NCP over IP. This is the Network Core Protocol over IP. However, that's because this machine is new. If this was the good old days, we'd be doing NCP over IPX, and I will attempt to demonstrate that at this video if at all possible. And then here, it's attempting to do multiple things. For one, it's attempting to mount a volume that is sys/my user ID, that's my initials. If you care, you can ask. Oh, stop scrolling. Okay, there we go. Wait. Well, okay, that was odd. It just like changed while I was in the middle of talking it. Oh well. This one right here is for 2 other drives. Syspublic is a common Novell share. Every single machine that's running a NetWare network is probably going to provide one. This right here is not necessarily an interesting packet, but it's going to do all this. So it's going to do Network Core Protocol, and it's also going to do NDS for Novell Directory Services. And this is where it's trying to query the domain to find stuff. And as you can see, the dissector for NDS is kind of not very complete. But that's the thing about all these older protocols, is that the Wireshark dissectors for them aren't very sophisticated. Okay, SMB netlogon. Don't be deceived. This is not actually from this particular machine. This is actually from a UNIX server pretending to be a Windows server, and that's where it does IPv6 neighbor solicitation. This right here is from the domain controller, so this is a bounce back. And I apologize. Why on earth is my phone ringing? Sorry, I apologize for that interruption. Okay, so this right here is actually a bounce back from the domain controller, where it's constantly spitting out on 2 separate protocols, because you can see the addressing form is different. It's spitting it out on IPX and immediately on IP. And the mail slot protocol is essentially saying, okay, this is now server thing being used. You can study the SMB mail slot protocol in more detail later, but it's blasting out a ton of packets for things that are available on this server. I guess that's a good way to put it. If you look through these packets here in the down here, you can see that this is speaking something about SNA remote access service, exact same thing. SNA demo 1 is a SNA link name on the SNA server. Management service, same thing. NetView alerter, that's something I'm not going to talk about. Anyway, so this protocol here is essentially a service beaconing thing, and this is something that we no longer use. We would consider this model to be kind of obsolete, but this is how it was done. And note very carefully, the source network ID on these packets is some kind of randomized address. This is the internal address for the internal network on my Windows 2000 domain controller server. It's being sent out to what it believes is Ethernet network number 2. In reality, the network number doesn't really matter per se. It's kind of, I mean, yeah, it matters for a routing table, but in the real world, no one ever cared. And then, of course, over IP, it's just hitting the broadcast address, but it's also hitting an Ethernet broadcast address, because remember, this host ID portion of an IPX packet is an Ethernet MAC address. So it's doing all this stuff. This whole time in the background, this other machine is screaming about some OSF domain, and we're going to look at that. It's pretty interesting. This right here is actually my workstation right here. It is a workstation server, NT workstation, a potential browser. And we're going to also look at some other interesting stuff as well with those browser packets. Okay, here's the actual Windows sign-on portion. So this occurred over... I'm going to walk you through the sign-on procedure here. This occurred mostly over IPX, seemingly. So we're going to start all the way back up. Okay, looks like right about here. So at first, that Novell client got to do its thing. This is where it attempts to resolve the NetWare server. Now, you may note right here, this looks an awful lot like LDAP. It's because LDAP is kind of a family of protocols that uses an address format called X.400. Okay, well, this isn't strictly X400, but it's pretty similar. And X400 is just like a general resource identification URL. Well, it's not a URL, but it's sort of an addressing format that is even used for email addresses. Often X.400 is synonymous with an email system that is now obsolete and no longer used. So X.400 addresses are used to first resolve that Novell server. Then we come down here, and this is where we actually do the real Windows sign-on. So first thing it's going to do is it's going to query that Windows 2000 server. So, okay, it blasted out. All right, great. Boom. Right after that, here's the name response. Then we're going to, hey, we want to do a SAM logon request. Now, what this is going to attempt to do is, on this older version of the Windows domain sign-on procedure, it will attempt to do a standard SAM logon, as in Security Account Manager or Security Authentication Manager. I can't remember which one it is. But it's going to attempt to do that first. Then it's going to say, okay, great, that worked. Can I upgrade to being Active Directory? So this is what it does. It attempts to do an active directory. And then this right here is the old domain sign-on protocol. So the forest DNS name is win2000domain.local. Okay, I know allegedly it's bad practice to use .local, but it's fine, really. And you can see the combination of sort of like the half step, because this is a Windows 2000 machine. This was the transition period from NT domains over to Active Directory. And even to this day, we're still in apparently that transition period. You can still join a Windows NT machine to an Active Directory domain on a Server 2016 box. But you can see the dual nature of this here. It has the DNS name, and then it also has the old NetBIOS name. So when you see that old Windows NetBIOS name, this is it right here. Here's the Active Directory NetBIOS domain name for pre-Windows 2000 clients. If you've ever installed a domain controller, you know what I'm talking about. It's it right there. Okay, and then it's going to do a Kerberos, specifically Kerberos 5, which I think is the only version that actually matters, and that's what it's doing. So there's the Kerberos ticket, and Kerberos is a really harsh and difficult protocol, but it supports and asks for all these different authentication protocols. And then all along, there's this IPX business going on in the background. Then it's going to attempt to do a actual SMB protocol negotiation. So it starts up an SMB session, and then it's going to want to do yet another NetBIOS session setup here. So here's NetBIOS session services. And then down here, we get into some more of the Active Directory sign-on details. So what it's going to do is going to connect to this logical share here called IPC $. Now, some of you may know that this is actually a bit of a security security issue. Some might call this an SMB null session, and this is potentially an attack vector, but you can go study this in any cybersecurity books if you're bored and want to read about that. but it's essentially going to try to query every single thing about the domain controller that it cares about. So it's going to enumerate all domains. So let's see what the response is for enumerating all these domains. Well, let's go down here. Enumerate domains. I think that it's going to be easier just to read the packet bytes. So there it is. It responds with Win2000 domain, and it's built into this domain controller. Lookup request. Well, what's Win2000 domain? Well, that is a domain controller. Well, it's also correct. And there's the SID for the domain. You probably have ran across SIDs if you've tried to take over Windows file permissions before. Then we're going to open the domain. We're going to look up the names. We're going to open the user, which of course is my user ID, which should be probably encoded in here. Nope, it's opening a pipe logical user ID. And it's doing all this, and we're going to attempt to access the SAM. Blah, blah, blah. Okay, there you go. So that's the Windows domain sign-on thing. Most of this is also done over a DCE RPC, that's Distributed Computing Environment Remote Procedure Call, which is a obsolete, yet for some reason still used RPC protocol. It was supposed to be for Unix, but Microsoft kind of jacked it for Windows, so there you go, DCE RPC. There's some more NDS sign-on stuff. We already went through that. This right here is where it's attempting to access a shared directory. Here's yet another SAM logon. So that's all good. This is where it attempts to access a netlogon directory. We don't have a netlogon directory, apparently, for some weird issue. But specifically, we don't have netlogon on a DFS volume. And that's distributed file service. Even though I'm calling this obsolete and outdated, it still works the exact same way to this day, more or less, except there's more security and more encryption. And then down here, we're doing the old-fashioned way. So what is the primary domain controller for my machine? Who am I registered to? I'm registered to Win2000 domain. And then we do this exact same SAM logon thing again. Great. And then down here, we're querying serve records on DNS for this machine here, except another domain controller responds to it because I've got Active Directory Federation going on with that, but don't worry about that. And then we do some proper DCE RPC stuff for bind. So we're binding the RPC session, and then we can start using that. A Kerberos error spits back out over that, so on and so forth. So, and then finally we get traditional LDAP packets over the standard LDAP port we all know and love. But I should make something clear here. I'm calling this obsolete, but this is modern, because this XP machine is really configured to be kind of a half step between modern and old. Haha, there's sysvol. You know, you can't do much without sysvol. Alright, but that's enough for that. Now that we know how to actually sign on to the network in this very obsolete manner that was long and rambly, now we can actually sit here and see our XP machine. Okay, great. So don't mind my old obsolete X server here. We don't need an X server. And ignore all the junk I have running. We'll go ahead and open my network places. And of course, the first thing you always do is you do view entire contents of network. So you do entire network for that. And we have all these many options of things that we want to see. So we have Microsoft Terminal Services, which for whatever reason does not actually browse appropriately. It's supposed to, but it doesn't. We have a bunch of NetWare servers. Well, by NetWare servers and a bunch of, I mean exactly one, because my other three are down. By the way, I'm producing a video really soon on a seemingly lost version of NetWare that will be coming out in an unboxing of it. Anyway, so we're looking at this NetWare 5 machine. Why did I click up? You know how long this is going to take. It's going to take so long. Anyway, we have several volumes here. We have this. This is actually a CD. This is just a CD that I stuck into a Novell server. And this right here, if you're a Novell head like me, is Novell GroupWise version 5.5. That's the installer for the client server. Here's a good old-fashioned sys. Sys is the NetWare system share that has a bunch of stuff. Ignore the clearly wrong size. There's no way it's 64 gigs. And some of these just have completely and totally, utterly wrong sizes. But public contains... Oh yeah, okay, I know they're compressed. Clear all. It also contains the NDS admin utility. So I can sit here and I can run the Novell Directory Services admin. I know this probably looks a little bit familiar. Maybe some of you have seen the Active Directory Users and Computers dialog, or perhaps the ADSI editor. You know, there's a lot of crossover with the PC networking world. This is a good example of it. But all of this is browsing a NetWare server over the NCP protocol. Now this one I'm barred from accessing. It says network name cannot be found, but it's actually a lack of permission. This right here is an administrative share. These are printer queues. I don't have any real printers. It's just this is a dummy printer. So on and so forth. So we browse a NetWare network exactly like how we browse a Windows network. So let's start browsing a Windows network. And this is pretty fun, I think. So I have a few domains here. Some of these domains are not querying. I actually have about 7 domains kicking around, but only a few of them query because we're on a slightly older version of Windows. For instance, my 2008 R2 and 2016 domains don't query at all. But we'll go ahead and browse. How about that Windows 2000 domain? So I have 2 other servers on this domain, but they take a lot of power and I don't really run them much. Here's us. We don't have anything shared at all. We don't have any scheduled tasks. For whatever reason, this shows up here. Here's a Windows 2000 machine, which we can also view the scheduled tasks, which there are none of. Here's a CD that may or may not be inserted. I can't remember if I left a CD in the drive. Okay, based on that really long response, I'm guessing I don't. Here's a shared directory that I can't browse unless I mount it. Here's SNA serve, which has SNA service clients and such. Here's netlogon, which you're not going to be able to see any files in. sysvol, that's of course Active Directory. And here's a laser printer, which is sitting right beside me. And then here is VLP for virtual laser printer. It's just a PostScript printer emulator that I wrote. I think that might be an interesting thing to talk about in a video sometime soon. But yeah, this is pretty much just your standard old Windows 2000 domain controller. If we come up here, we can browse an NT4 domain. So I have an NT4 server that has a lot of the same stuff. There's good old netlogon. This has also got an SNA server, but it doesn't really have a user share. I have that on this NT 4.0 Enterprise server, which I aptly named because it has 4 processors. We'll see how long it takes to query. Now this is going to require a separate logon, so I do NT4 domain with the exact same username and password. And after that machine decides that we're authorized to talk on the network. Oh, I missed a 4. Okay, there we go. Hurry up. You know, normally this wouldn't take so long, but we're on some ancient hardware here. There we go. Okay, so we have the CD drive, which may or may not have anything in it. Well, I guess we're about to find out. Nope. See if we can access that shared directory. Nope, we're going to have to manually map it. This is a kind of a side effect of having the Novell client installed. There's a bug in it. Well, I don't know. Maybe it's a bug, maybe it's a feature. I'm calling it a bug because I like to call things bugs that I don't like. So it's trying to query a Novell server with the name nt4 intserve, which of course doesn't exist. Here is the exact same printer. Well, we don't care to wait on that. But yeah, so there's also this OSF domain. What's that? Well, we're going to look at it in a little bit. It is actually a PATHWORKS server, which is a LAN server emulator for digital UNIX. We can also do stuff like NetView and use that to, oops, okay, let me see if control break works. Nope, I guess we're stuck. Well, while we wait on that to fail on us, we'll do NetView digital. Oh man, yeah, I'm not surprised. How about that server? I know you're wondering, hacker, what are these weird names you're typing in? None of these show up in the browser. Well, that is because I actually have several other domains and they are running on actually not Windows. There's a PATHWORKS server package, which was one of DEC's most famous products, and it runs on digital UNIX and it runs on VMS and later OpenVMS, and it is a Windows domain controller and server emulator. However, for whatever reason, we can't browse on here, so after a while we'll downgrade to Windows NT 4.0 and we'll browse there. But that's pretty much the gist of this. Now, there's a ton of other networking protocols that we're going to look through as well. Okay, great. I got to gun this right here. Let's see. Where is it? You know what, we'll just do that. That's good enough. There's other protocols that we can browse, other obsolescent protocols. How about that other one I mentioned, DECnet? DECnet, what's DECnet? Well, let us actually look at our Ethernet connection here. If we look at the properties of this, and unfortunately have to scroll, you'll see that I have Novell client for Windows. I have Windows client. Well, okay, this is the workstation service, and this is the server service. If you know, like NetStart workstation, NetStart server, this is what they correspond to. We have Personal Communications LLC2. This is for SNA. Now, I've made plenty of videos talking about SNA, but SNA is IBM's mainframe network protocol. This machine does talk to mainframes. We have DECLAT, which is a terminal server protocol we'll look at in a second. This right here is the DECnet protocol driver. This right here is an intermediate driver, which is used exactly for transmitting and receiving packets. We have IPv6, we have NetBIOS, we have IPX, and specifically NetBIOS over IPX, and we have IPv4. Okay, so let's start browsing some of this other stuff. We've already seen that we already have a mixed mode IPX and TCP/IP network deployment here, but there's actually something else that we have at our behest here. We have DECnet. What is DECnet? Well, everyone knows with TCP/IP. Everyone, I mean, who doesn't know TCP/IP? I mean, really, this right here is like bog standard stuff right here. Granted, this right here is like literally the most generic Linux on the planet. It's literally like, it's not even anything specific. But this right here, everyone knows, just good old-fashioned telnet. I mean, this is nothing out of the ordinary. Ignore the fact that my terminal just went into hieroglyphics mode. But that isn't the see-all and, sorry, the, whatever the saying is, it's not the be-all and end-all of networks. There are other network protocols, and one of those is called CTERM. You know, we can telnet into 192.168.1.55. Yeah, but you know, that's boring. I want a CTERM into it. So we plug in 1.21. What's that? We get the exact same thing. And we'll go ahead and sign on in, and we'll switch back over to our packet view, and we'll look at our network traffic here. What have we here? No, despite how much anyone pays me, I'm not going to say, oh, whoa, what's this? Okay, so this right here is a DECnet session, is what's going on here. So a DECnet session is kind of like a TCP session, if you will. I don't mean an IP session, I mean a TCP session. So you get like all of the transmission in ACKs. Properly, it's called NSP, which is for Network Service Protocol, I think. And this right here is pretty much, for the most part, kind of like TCP/IP, but kind of scaled back. So notice the odd addressing here. So what's going on here is, first it's going to ask the router, because 1.50 is the default router on my network. That's a Cisco iOS 12.6 machine, which we might look at just for fun. Actually, we will for fun, if you know what I mean. It's not that fun, but yeah. And the router's going to bounce back and say, hey, you know what? You're already on the node, so talk to the node directly. So we're attempting to, so 1.36 is going to try to talk to literally anybody. And this machine's node name is PC2000. This is the standard response name, if you will, for a Windows PC running the PATHWORKS package. Now, I know earlier I said PATHWORKS was a LAN server emulator, and we will look at that. But PATHWORKS is a LAN server emulator, and also the name of the client. It's terrible. And PATHWORKS is the DECnet stack for Windows, DOS, and OS2 and Macintosh, as in like classic Mac OS. But at this point, the connection will kick off. So there we go. You know, link control message, initiate. So this right here is basically our SYN. Here's our SYN ACK. And then bam, now we can actually start talking here. So the packets will flow in. And then after enough iteration, we may actually get something here. Let's see if we can find something. Oh my goodness. SNMP is a horrible protocol. Anyways, not looking at that. You can see the action here. It's 1.21 to 1.36. So 1.21 is the network address of one of my VAX VMS machines, and 1.36 is the network address of this Windows XP virtual machine. So if I do show user, you'll see I'm logged in. over presumably something. And if I do show user, I think this works. Show user full. There we go. I'm signed in. So my username is WC, process name WC, ignore the PID over terminal RTA1, and I'm coming from this strange hashed node name with the logical name of PC2000. Now I can do show terminal, and you'll see up here that I'm coming in from, for some reason it's still resolving me as 1060, but you know, it is what it is, I guess. It's kind of weird, but that may be a bug in PATHWORKS. I'm not actually sure. But yeah, we're actually signed on via DECnet, and I can sit here and emit a ton of packets, and if we go back and look back at our Wireshark trace, I can scroll down a little bit, and after scrolling my finger off, okay, maybe I just should have went up. Okay, who knows? They're all interspersed throughout here. There's some of them. So there you go. Now, speaking of protocols working on different systems, I still have this Linux session up, and oh great, I'm actually gonna have to restart this because I hosed the terminal. We can actually do dlogin. No, it's dn login. There we go. Dn login 1.21. I can log in over DECnet from Linux. If I do a show user, you'll see I now have two. I can do show term. I'm coming in from LNX VM, which right here is a name. If I run a program called NCP, I can do show known nodes, if I can type, and there's a mapping of every single node, and you can see that this Linux VM has some sessions started on it. So there's one active link to Linux VM, and that's because I'm sitting here signed on and working. And you can see also my XP VM, which is actually not listed on here. I haven't plugged it in and stored it in the node database, but it's here. And I can actually exit this, set proc/priv equals all, mcr ncp, set node, see if I can remember how to do this, help set node. Nope. Help define node example. I never remember this. This kills me every single time. Okay, there we go. So set node xpvm address 1. I think it was 1.36. Show no nodes. There you go. Now I'll show up and show no nodes, so you can see I've got an active session. This right here is this right here, and then this right here is of course telnetted into that Linux box. Oh my gosh, I've been in the wrong view the whole time. Oh, that's a massive blunder on my part. Oh, I'm horrible at making videos. Sorry. Anyways, what I did there was all of this. I was showing a active session here where I'm signed in from this Linux session here. I signed into that, and I went over DECnet, and then I ran a program called NCP, which is a network control program. Then I plugged in the node address for this XP virtual machine here, because this right here is this Linux machine. You can see I'm signed on to this VAX VMS machine via Linux and also via Windows XP, and they're both coming in over the exact same Ethernet circuit because the machine only has one Ethernet card, and the next node, aka the router, that's a weird thing to call the next node, is all the exact same thing as this 1.50 Cisco iOS box. So we'll go ahead and log out from that, and there is actually a DNetStat equivalent thing here. Now unfortunately I don't think that I can do, actually we'll try it here. We'll do set host. This right here is the equivalent of like the telnet command on VMS for logging in via the DECnet CTERM protocol. We'll do set host Linux VM. Hey, look at that. Ignore how bad the performance is. I don't even think this works. Holy ever-loving smokes. This is so laggy. Anyways, you can see that I'm coming in from my 1.21 VAX VMS machine, because this right here is tied into my VMS, and then you can see I'm logged into that. Now, unfortunately, if I log out of this and I restart the session and let's see, what was this thing's address? I got to figure out what Linux VM is and number. There we go, 1.7. it's utterly incapable of talking to it. For some unknown reason, there's a bug in the Linux DECnet stack that makes it impossible to connect to it from anything but VMS. I've tried every other operating system that supports DECnet, literally every other OS that supports DECnet, and none of them can talk to it except VMS. So we'll just leave that to rot and wait out on us. So we'll go ahead and log out of this Linux machine. And, let's start to think, what's something that's really cool and neat? Well, to me, it has to be X Windows. Everyone loves X, right? Everyone's about this new Wayland thing. Well, I bet your Wayland doesn't work over DECnet. Wait, what? Okay, so let's look at this. So I'm going to restart that program I killed initially when I logged in, which is Xvision. And Xvision is configured here as an X server with this window size. We are on server display number 1, so this right here is, well, you'll see what I mean. And we are going to do an interesting demonstration here. Oh, I've got caps lock turned on. So, I don't know if many people know this. I know a lot of people know that X is a network-centric protocol, but no one really knows what that means. So what we're going to do is we are going to demonstrate what I mean by X being network-centric, and we're going to do it over 2 protocols. We're going to do it over IP, and then we're going to do it over DECnet, which, by the way, you can still compile xlib to this day on Linux with DECnet support, so don't let anyone hold you back on your vintage mainframe protocol networking affairs or whatever. So everyone knows, like, you can do echo $display. But of course we don't have a display because we're logged in over a telnet session. So how do we get a display? Actually, you know what? Let's up the ante a little bit. Let's do something even weirder. I'm using the LAT here. I'm using telnet here. We can also use something called LAT. And LAT is another terminal server protocol that's basically the sole purpose of it is just to do like remote login. And we can sit here and we can switch back to our Wireshark view. And this time I promise I won't mess it up. But you can see that there's LAT. So there it is. You just do a session initiate. It's literally just start, and then run. Boom, Linux VM. Boom, dev PTS 0. Blah, 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 blah. Login. LAT is like legitimately, I think, one of the simplest Ethernet protocols out there that does something useful. And it's pretty basic. I mean, it's got like MTU and it's got AX and all that stuff. But actually, no, it doesn't have AX. It's pretty much just like UDP telnet over Ethernet without any link layer on top of it. But yeah, the way that this works is you have a terminal server, if you will, that runs, and this terminal server box would have been called a DEC server, and you plug up serial port dumb terminals to it, and then you push a terminal where you push the power switch on your terminal, turn it on, and you say, okay, you can connect all these cool nodes. Okay, we'll connect to whatever node, and the terminal server will initiate a connection to this remote node via LAT, and various operating systems from the era support that. So you can see obviously Linux supports it, but that's obviously new. If I open up another PowerTerm session, you'll see that I have this right here is the digital UNIX. This is an OpenVMS, so you see I can connect to OpenVMS. Everyone knows what the VMS login screen looks like. I can connect to digital UNIX. This right here is just, OSF1 AXP running on an alpha that I have. Here's Cisco iOS, password required, but none set. Okay. I expected that to work a little better. And of course you have Linux. But LAT is a pretty simple protocol. The open source LAT-D works on pretty much basically anything that's not Windows. It works on Linux. It works on OS 10. What is this? There's garbage here on the screen. I don't know what that is. Kind of weird. Anyways. So we're logged in to this. Of course, this doesn't work. And of course, I can't do a netstat either because it's not going to show up on netstat. But I am logged in over LAT here. And it works kind of like exactly what you'd expect. It's just like Telnet, except... Okay. I think the LAT service just died. Unable to connect to LAT service. Okay, as you can see, the open source quality is pretty good, but it's not the best. So we'll stick to Telnet. We'll stick to Telnet for our X demonstrations here. So we have this X server here, and I said it was on display 1. What does that mean? Well, you know, we have the IP address of our XP workstation here, so we're going to do something like this. We're going to do export display equals 192.168.1.51 colon display 1.0, and it's 99% of the time it's .0. And I know my cursor blinking stops, so let me reset the terminal to get that to work. There we go. Well, that still didn't work. So at this point, I can actually just start running X stuff. So I can do TWM, and as you can see, we didn't get any error about not connecting, and you know what? Lo and behold, there we go. I can plop down XTERM. I can set the font that doesn't work. I can enable reverse video. Turn the scroll bar. What other stuff can I do? Enable visual bell. Show tech window. Why not? Do I really need this? No, I don't need this at all. Anyways, so that is the general concept of X. I mean, this right here, this is actually a network, and as you can see, this is a good frame rate. But, you know, this is boring. Like, who's actually unironically using TWM? Not me. In this house, we use, well, how about user vt bin x session? How about we start up CDE? Everyone knows CDE. It's the crap desktop, common desktop environment. Who knows how long this is going to take? It's probably going to take a hot minute. But CDE is the original Unix desktop, and based on the fact that it's taking this long to open, I'm guessing something probably went wrong. Could be any number of things, but what makes CDE special is that it was common to everybody. Actually, we'll demonstrate CDE on a different system. We'll do something that's actually native to Linux. How about Window Maker? There we go. I knew it had to be named something. There we go. I know I made it blue. It's kind of stupid. But yeah, I mean, we can just use Window Maker like it's just normal old Xorg running locally. But we can do cooler stuff. You know, I want the full Next Step experience. For those of you who don't know, Window Maker is a clone to the Next Step desktop environment. We can run G Workspace, and we can get the real deal. Like, actually. So, we just wait on that to open up. And here's our file viewer. It looks identical to Next Step. Here are programs we can run, that none of which actually work because I kind of borked it. And we can open up the terminal, which opens up XTERM, but we don't want XTERM, we want terminal. Yeah, so this right here is actually the Next native terminal. And this is going over a network. This is actually it's emulating a Linux console terminal of all things. And it works pretty much like a charm. We can run GNU mail. Yeah, I guess that's okay. I don't actually want to go through setup. Okay, that's good. Anyway, here's a mail program for GNU Step / macOS. This works on OS 10. You can go compile this program on OS 10. It's supported natively. And just a bunch of other stuff as well. Anyway, you get the gist. This right here is X over DECnet. And if we flip over and we look at our hideously long packet capture list now, you can see that my scroll bar is all the way up here. Holy ever-loving smokes. This was all our progress up to this point. Boom. Now it's all X. Yeah. Every now and then you'll see something like, actually that's an X11 packet. The rest of these are just processed data packets and payloads for X itself. But other than that, if we scroll up to the top of our X ordeal, you'll be able to see kind of the basic stuff. So there we go. This is the basic stuff. So it's the whatever program this was that we ran is going to query every single font on the server. So that's what it's doing there. And of course, these are the classic X font names. This isn't really a video on X. This is a video on just old networking. But yeah, there we go. So that's not too terribly difficult to do. So there we go. There's some action that's occurring, so on and so forth. But, you know, that's great and all. But X does not exclusively just work over DECnet. I'm sorry, I just spelled it. X does not exclusively just work over IP. There exists an X server that can actually do X over DECnet. And yeah, I'm not even kidding. It actually legitimately works. And it's called Excursion, which is got to be the dumbest name for an X server, but it's actually really good. So this is the final version of Excursion from 2000, which, despite being that old, can actually hold a candle and run plenty of modern window managers and such. And even XCB works. So if you have an XCB-based like a window manager or desktop environment, it will work on this old X server. So keep that in mind. So we're just going to configure this one to run a single window at this right here, and this is going to be on server 0 rather than server 1. However, I have no idea where that is supposed to be. So we'll start up the server, and at this point we can do the exact same thing we did before, but this right here is doing both IP and DECnet. So let's start up a DECnet something here. Okay, great. We're just going to be waiting on this for 20 years. Don't send. I hate that feature. Alright, let's start this up, and we're going to connect to... We'll start simple. We'll connect to that digital UNIX system. However, I need to check my nodes list to figure out what that was. Actually, you know what? We're just going to guess. Actually, I have a sticky note on the wall. 1.4. So we're going to log in here. If I can remember what my username and password is. As you can see, I haven't logged into this machine since December the 3rd of that long ago. Actually, there's not even a year, but wow, this is a long time ago. Okay, so what we have here is a standard digital UNIX machine, and this is more or less Digital's version of OSF1. There are other versions of OSF1 AXP. IBM sold them for mainframes, and also PS2s, but we don't care about those. We care about this one. So we can do the same old, same old. So we can do display equals 192.168.1.51.00, export display. This old version of this shell requires you to do that, and we can do user dt bin x session. And we can start up CDE over here. And it does take a... You must be root to run this application. What on earth are these fonts? Okay, I lied to it when I told it what my screen size was, and the fonts are massive as a result. I said my screen size was like 17 inches. In reality, that's not the case at all. Okay, anyway, you get the point. It is kind of screwy. Let's change that. Font? Yes, please. Okay, exit the desktop and log back in. I'll be happy to. Oh, great. We're going to restart the server for that one. Start server. Maybe that'll work. Nope, that never works. Wait, who am I kidding? I'm on the corn shell. Why would that work? Alright. This time we won't see garbage. Alright. Okay, you know what? I'm going to give up. Maybe it's just not going to work too well with the fonts. Anyways, this right here is CDE. And I think everyone's pretty decently familiar with CDE. You know, same old, same old. There's our calendar manager. There's the mailbox. What even was that? A copy of your... whatever. File browser. All of which suck, of course. But anyways, this right here is X over IP. But, you know, that's boring stuff. I want X over DECnet. So let's log out, and we're just going to terminate it all together to make it expeditious. And we are node 1.36. So what we're going to do is we're going to do display equals 1.36 double colon 0.0. Export display user dt bin x session. Okay. And well, what do you know? Quick, switch over to Wireshark. I want to see that junk fly. Well, you're going to see a whole lot. Let me click around and do stuff while that loads. There you go. There should be... Oh, great. The other X session's still running, and it's in my way. Because it's on 102. I want to say .1.106. But if we scroll around, there you go. There's some DECnet X packets. And if we look at the routing control, let's see if I can figure out the object node and all that. I guess not. If we scroll up to the top, we'll be able to find the initialization packet. But something like that is going to be way... There we go. Connect confirm. Alright, so we want... Let's see. Which one is it? Session connect data. Session destination. There you go. So we are connecting to $X. Now, if you look at like a CTERM packet, it's going to be CTERM. So that's what we're doing here. Okay, yeah, the DT messaging, yeah, okay, that never ceases to amaze me. That always fails with DECnet. Anyways, uname-a, echo $display. We are Xing over DEC, you know? Yeah, okay, I know ToolTalk doesn't work for some reason. The reason that doesn't work is because the ONC RPC system on Digital Unix / OSF1 has been enhanced, if you will, to be able to resolve DECnet node names, and this machine's node name, this XPVM, equate to 1.36 hasn't been keyed into the NCP database. Anyway, ignore the fact that my keyboard layout is wrong on here. Oh yeah, great, we have all our files and such. Whatever all this stuff is. We can even use Netscape. You know, how beautiful is that? Who knows how long it's going to take to open. This is a kind of a slow DEC 3000 AXP, the original DEC machine. Anyways, you get the gist. So that's X over DECnet. And we can also do this actually from OpenVMS. So we'll go ahead and gun the server to kill all those programs. And we will sign back into VMS. So 1.21. And yes, X does work over TCP/IP. And you can do that with set display /server equals 192.168.1.51. Wait, no, set /display equals node 192.168.1.51 server equals 0 /transport equals TCP/IP /create. And then we can do run sys$system. Quite hard to type with this microphone in the way, and then this voice changer circuit box sitting in front of me. Okay, so it's kind of slow because it's VMS, but I apologize for the awful color scheme. Actually, if I log out, we'll see the login screen. Most of the time we'll see the login screen. Yeah, there we go. Alright. We'll go ahead and log in, and then it will actually look like the right color scheme. Of course, waiting 20 years for that to occur. But this is X over IP into VMS. So CTERM. Great. I love how slow this is. Slow show display. There we go. So, alright, that's pretty trivial, I think. And we're going to do it over DECnet. So now we're going to set... Oh, that's right. Hang on. I got to stop the process ID before we do that. Show sys. Stop /ID equals, which one is on the chopping block? Ha 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 ha. We'll say 6B4. Oh, B6B4. Oh my gosh. Okay. Now we have some peace. We're going to do the exact same command. So, except this time we're going to do transport equals DECnet. And our node is going to be 1.36. Now we're going to run sys$system dec window $start login. Okay. Just like old times, except this is like lightning fast for some reason compared to IP. Who knows why that could possibly be the case. DEC chart? Oh my goodness, I'm about to make so many charts. Okay, that right there is just like our notifier thing. CTERM. Which, by the way, CTERM is extremely good. It's the most accurate emulator. So if I do Office, like open up the Office server thing, you can see we got this weird double width font that most people haven't seen. By the way, only XTERM can do double width fonts and other strange VT100isms. Alacrity, Kitty, and Console with a K can't do any of those. So if you're running legacy applications or you like to maximize the features that your old CRT terminal in 1975 could do, that your terminal emulator in 2024 can't do, use XTERM. Of course, show display. Whoop-de-doo. We're good to go. So that is X over DECnet. But there's even more we can do. Of course, there's always something else we can do. What have we looked at this point? Well, we've looked at Novell NDS. We've looked at X over TCP/IP and DECnet. We've looked at LAT, CTERM, and also good old-fashioned Telnet, which I don't think is a shock to anyone, although I'm sure there's someone watching this video that's never seen Telnet in action, but, you know, you should probably learn about it somewhere along the way, because Telnet's a great tool for testing network protocols. But there's even more weirdness that we can do. But to do that, we're going to have to change out of this machine. So I'm going to stop this video here, and I'm going to restart videoing when we're logged into another machine. From widescreen to square screen, now we're looking at Windows NT 4.0. So we're going to go ahead and sign on to a Windows NT 4 terminal server here. And what this is the original RDP server. Now, this particular machine has been configured with a variety of protocols, and as a matter of fact, I can access it over protocols besides just what we're seeing here, but we're just going to browse it for now over what we already have, which is this RDP client. This RDP client is actually just running on Windows 10. So we are currently signing on, apparently for the first time, into this Windows NT machine, and while we wait on this, really what we're doing here is we are going to examine some machines we could not previously see on our LAN. So let's go ahead and fire up Network Neighborhood here. Of course, when that one guy asked where the hood at, to me this is where the hood's at. So, okay, hang on one second. That's got to be fixed. Options, yes. View, show all files. Okay, thank you. That will keep me sane. All right. So we have three network options here. We have the client network, which all this is basically the RDP client that we don't care about. And we actually just closed that because it doesn't do anything for us. We have our NetWare network, which of course we're not signed into Novell directory services here because we explicitly said no, that we don't want to sign in, but we can sign in if we want. It's because we're not signed in. And then here's our multi-domain network again, except this time we have some others showing up. We have this OSF domain, and you may recall that digital Unix server that we had running before. That has something really interesting in it, and we're going to look at that in a second. And we also have this VMS domain. What? You mean you can run a Windows server on VMS? Well, yeah, I've been leading to it the whole time, and I suppose it's high time that we actually talk about it. And once this is done, we may actually take another look at yet another machine. I don't know, this video is already over an hour long, but I wanted to try to cover literally as much as I could about old networking protocols. But I have another machine, a real iron machine, actually sitting right beside me that I will actually have to break out a camera, and you'll have to unfortunately look at me. But we're going to be looking at some serious hardware in that one. But here we go. If I look at the properties of this, you may be surprised at what it identifies as. Let's see if we can get the properties to show up. Maybe, maybe not. While we do that, we'll open up a command line here. And we're going to oh my gosh. This is going to really drive me insane. NetView OS2 domain. Yeah, I have a domain of OS2 machines as well. Like, what are the chances of that? Well, you know, Microsoft wasn't the only one selling LAN servers back in the day. Now, this probably won't work, but we have several of these machines that we can browse and look at. Now, unfortunately, the consequence of this is that... Okay, now we're okay, that makes sense. The consequence of that... yeah, see, this is the gotcha. This is the suck factor about this old PATHWORKS server, is that it wants all this licensing thing. So we'll have to figure something out with that. And I do have a solution for that. We're going to look actually on that Windows XP VM. We're going to go back to that to figure that one out. Yeah, blah, 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 blah. Anyways, this right here works pretty much exactly like you would expect, and this is honestly pretty much the exact same thing, but I can also net view that OS2 server, and if it decides to work, who knows, the machine might be crashing, needing a good kick to make it reboot. But if it decides to work, we'll be greeted with a whole list of shared directories and such. I may need to just do it the manual way, where I just manually plug in the username and password for it. Yeah, access is denied. Let's see. Does this... actually, no. We'll actually do NetView domain. Of course, that works like a charm. Sometimes this works. I think this works on the older versions of Windows NT. Most of the time it doesn't, though. But if we go and we look at our network traffic, and we snap down to the bottom, you'll be able to see that there are packets flowing out from, actually, never mind, we're not going to be able to see it because this isn't working in promiscuous mode. Oh well, we're still out waiting for that one. But we can do all the exact same stuff we did before, except we can do it with style. We can use this older version of PowerTerm. This is version 5.2. Wait, I think that's the same version. Oh well. Anyways, we can do the exact same thing. But this particular machine is of interest because this machine is... Okay, there's no entries in the list. Alright, makes sense. This machine is of particular interest because it actually allows us to do SMB over DECnet. Yes, I'm not kidding. That's actually a real thing. And we're going to look at that in great detail here in a little bit. But right now, we're going to say that this is just a basic Windows machine. Actually, if we go into Network, we'll be able to look at the protocols and the associated bindings. Let's see. Oh yeah, that's right. We can't view the bindings unless you're looking at the setup. Anyways, we have all these protocols running, but one of those, you see, we can't actually do anything about it. But anyways, the server and workstation services are configured to run actually over DECnet. So we can actually talk to those Windows file servers over that. But that's going to pretty much wrap it up for that. We're going to switch back to XP because we're going to attempt to look at some particular machines that really require a little bit of an older protocol to access. So we're going to do net use, what's a drive letter that isn't being used? Of course, Y. You're probably wondering, where does drive letter Z come from as the default file share? Well, before Windows networking was really a thing and it was really good, Novell clients would always mount Z as that first one. Actually, you know what? Let's just mount some random shared directories here. We'll mount //os2 server /share /user is os2 domain /admin. And we're going to say our password as well. You can probably guess what it is, but I'm not going to say it out loud, but just figure it out from the letters I push. And this right here, well, look at that. File system HPFS. You know, this is something that a lot of people don't really get to see, is like the file server, or like all these different file servers actually report the native file system that they're storing on. So NetWare, of course, uses NWFS. OS2 uses HPFS. There's the volume letter of that. Unfortunately, the thing about Windows NT and onwards is that they don't allow you to really do like a dummy session sign-on, or as I like to call it, a null session sign-on. Because if you look at the network client on Windows 9X, you can type in any username and password you want. It literally doesn't matter. You can plug in literally anything, and it will say, hey, that's good, because all it does is just blasts out to all the LAN servers on network. Hey, I'm username, Emma, password 123. That's definitely not my password, but yeah. You all saw that it was earlier. Anyways, so this is a pretty good example. Of course, if you do like a normal share, if you will, we can't use Z. Who am I kidding? We'll have to use X. We'll use my actual account for that. There we go. We already had a cached password from that earlier. If we look at this, this is NTFS. But can we take it further? Can we make our life even more difficult? Well, the answer is yes, we absolutely can. And if you excuse me, I've got to pick a CD-ROM image that I do not have downloaded. So I'm going to have to pause the video and install a package really quick that will allow us to access those two other file servers, that OSF domain and VMS domain. So let me do that lightning fast here. Alright, so we're going to, and I'm actually going to try to make this lightning fast, and I'd like to interject here with a note. You need the license LAN manager request. You need this stupid thing that's on the PATHWORKS CD. I'm using this version because it supports XP. But if you have the concurrent use licenses installed, I don't have concurrent licenses. The licenses I have for PATHWORKS are all like the stupid seat kind, so you have to install this awful license requester thing. But if you're a hobbyist and you're not doing it for commercial purposes, install a license for PATHWORKS that is a concurrent license. You can access it from anything, and PATHWORKS is probably one of the more compatible SMB servers because it works anywhere from OS2 1.x all the way up to like Windows 10 can mount it too if you're really clever. However, now we have to sit and wait 20 years for this thing to register the protocols. So while we do that, let me explain what's really going on here. So if we read the README for this, well, I guess read what? How did they do? Oh, this is probably that that autoplay.ini file. Anyways, they have all these. Okay, now I'm really curious. Yeah, there you go. Anyways, if we sit here and read the release notes, you can tell that this was obviously spat out using the program called DECnet. This version here does not support Win9x. You need a slightly older version of PATHWORKS for that, but of course you can find it. Good golly, this is going to take 20 years. Anyways, this provides the following things. This now has Windows 2003 support, which of course means Windows XP. And Excursion actually now supports multi-monitor support. Now, I can claim I have actually ran plenty of multi-monitor remote X sessions. It pretty much just works out of the box as is. Alright, well, we got to reboot here, so I'll go ahead and pause this and I'll resume back when it's done. Alright, well, let's go ahead and boot up here. And by boot up, I mean we're probably already done booting. Yeah, I'm using that ridiculous video card driver. Anyways, so this right here is going to spawn something new after we sign in. So what this will do here is, if this will hurry up and work, we're going to sign on to our Windows domain. Oh, oops, I didn't sign on to NetWare. Well, not that we really care, we've already demonstrated NetWare. But eventually, if all is well, this will pop up. And this right here is going to request a license, and it's going to pull it from one of the LAN servers that I have, which one of the two PATHWORKS servers I have, they're both either running on VMS or OSF1 AXP, or as I like to call it, Digital UNIX, because that's really what it calls itself. So after this claims the name, and if you sit here and what happened to VirtualBox? Okay, hold on, this is a travesty. What in... Okay, great. You know, I always have problems. There we go. Okay. Anyways, we should now be licensed, but if you flip over and look at our Wireshark packet capture stream, if we scroll down to the bottom, we'll probably be able to find somewhere in here, we'll be able to find those LAN manager license packets. There they are right here. So this is talking to 192.168.1.183, which is, of course, the Digital Unix one. So it queries the special name. We still haven't talked about browser. We're going to talk about browser in a little bit. But it queries that special name and acquires a license. So what we can do at this point is go to My Network Places, view the entire network. That's not what I meant. I meant entire network. Browse our Microsoft Windows network. And, okay, well, we haven't had a browser packet yet, but we can actually do a map network drive. We can augment this. We can browse this, and we can mount that and we need to connect using a different username. We can mount digital/share. At least I think this should work. I'm going to be honest, I have no idea what my password is. I guess we're about to find out if I got it right. If not, I'll brute force it a few times until I get in. You're already logged in. Do you want to? Yes. I guarantee that's going to cause a problem. Yeah, that's what I thought. Oh my gosh. Yeah, thanks Novell for making a piece of crap client. We're going to have to do it the old-fashioned way. NetUZ//dig. Actually, you know what? We can do NetView. I think, yeah, okay, access is, alright. Okay, by the way, I should make a note about this. Sometimes you can do this, but oftentimes on newer versions of Windows NT, you have to do it like this. And even then, it's probably not going to work because it doesn't respond to browser packets the exact same way. Oh, nope, there we go. So if we look here, you'll see we get PATHWORKS for Digital Unix Server. Now we can also maybe let's press our luck a little bit, and let's view the VMS domain, which has another PATHWORKS for OpenVMS server sitting on it. Why I did not combine them all into one domain is bizarre to me. I don't know. Maybe I was chasing Flex for the most number of Windows NT domains that a person has in her house, but who knows. Anyway, while this sits and loads, we'll actually go ahead and mount a drive. So we'll do netUZ, and we can't log in because the Novell client is kicking our butt, so we have to do it this way. We just have to know what the shared path is. Oh, there are no entries in the list. Yeah, I'm not surprised. It's probably cloaking itself for some reason, or it's using an older version of the protocol. So user will be OSF domain. Please work. If not, we'll log in and change the password. Which might as well look at it anyways, because I think it's kind of interesting. What was it 1.4? Yeah. Okay, alright, so we're going to do net. So net view. Oh, you're probably wondering, what on earth am I doing running this net command on Unix? You know, normally we've been sitting here typing net on Windows this whole time. Here's this net command on Unix. Oh, it gets better. There's a net command for VMS too, and OS2, and DOS, and like 50 other operating systems we don't care about. But we're sticking to our guns on this one. So we're going to do net user WEC star. Ah, that's right. Oh yeah, I can't push up because this is an old corn shell. Okay. What? Oh. Alright, great. Now I can sign on. Probably. If we can't sign on, it's because it's not transmitting an old enough password hash. I'm going to need to edit the group policy for that to take effect. I know, imagine having to edit the group policy. It ain't going to work. I'm already going to tell you it's not going to work. Because this is trying to do NTL and password hashes. Holy smokes. File system, UFS. Tell me that ain't the worst thing you've seen. And the sad part is, this is doing... I think it's doing standard TCP IP. You know what? Let's log in and look. I'm not log. We already logged in, but we can sit here and we can look, and we can actually scroll all the way down, and we can figure out what protocol is it trying to use. You can see that NetWare client's flipping out. Yeah, okay, yeah. So it's doing IPX. But if we sit there and edit the binding, we can have DECnet come first in the binding ordering, and we might look at that here in a little bit after we look at our browser packets. But yeah, I mean, for the most part, this will pretty much just work. Now, there is something that we can do here. We can run the license configurator, which has a very specific icon. Where is it? No, that's the... This right here is basically the DECnet version of FTP. We can connect to 1.21. There we go. So this is like the DECnet version of FTP. It's called the FAL, File Access Listener. There is a FAL server for Windows, but we're not going to demonstrate it today. Great, the LAN manager licensing configuration thing isn't here. Good thing I have it on the CD. So it'll be under here. Let's see, which one of these is LAN config? Okay, we are going to add 2 remote license servers. Let me plug those in really quick. Oh my goodness, I've been in the wrong... Again, I suck at making videos. I apologize. The video production of this is awful. Oh well, anyway, let me plug in the correct license server here. Oh yeah, okay, hold on. Alright, I plugged into the license server names, and now we are presumably about to request them from 2 different servers now. And if we go over and look at the packet capture trace, which I will now hopefully remember to switch back from, we'll be able to see where it's doing all the... Actually, it already finished. Alright, good. So, in theory, we should be able to maybe, just maybe, view everything. Let's see. Oh yeah, of course, this still doesn't work. We'll try. We'll try browsing the domain anyways. And in the meantime, we will... I'm gonna need to open up a new one for that. Let's see. Oh yeah, the NetWare client sucks. Let me tell you, it sucks. Because this is what happens. If there's an invalid name, it just, oh, I see you probably mistyped your Novell server name, and then you just get this crap, you know. Don't try this at home, kids. You'll hate yourself for it. Okay. Let's stay focused, because this isn't going to help itself. This right here is, well, you know, we can't do it this hard way, so OSF domain, go ahead and sign in on that one. Wait for it to do a sign on. By the way, for these newer versions of PATHWORKS, they do actually prefer, they do properly prefer IP. I would also like to make another note. The version of PATHWORKS that came after DEC sold off DEC to Compaq, which is Compaq Advanced Server for True64, can be a Windows 2000 Active Directory domain controllers. Okay, so what is all this crap? What's in share? Who knows? DOS util. None of these are going to work because I have to sit here and use the command line like an idiot. What am I? This is so dumb. Oh, you know what? Pick a letter. Who cares? Alright. Now we can browse our beautiful shared things all on UFS drives. You know, it's amazing how that works. What are these OS2 utilities? These are exactly what they sound like. The OS2 LAN server client does not properly have versions to, I guess, to manipulate UNIX style permissions on the server. PC common. Wait a minute, I've mounted the same thing twice. This has more useful stuff. And by useful stuff, I mean absolutely nothing. What is all this crap? I don't even know. Oh yeah, I remember what this is. This has a version of libretro for like Windows NT. I wonder if the dates are correct or not. Yeah, they are. This is when I did this. Okay, anyway, so there you go. If you need a cheap Windows, and by cheap I mean free, Windows file server that works for both Unix and everything else, I can't recommend PATHWORKS enough. Okay, so let's see if we can log into that VMS domain, because this has been a thorn in our side for a hot minute here. We may actually have to reboot if it becomes hard enough, but let me make double sure that... Okay, great. You know what? We're not going to care about that. We're going to do net view. Let's see if we can view our mighty VAX server with its non-NTLM hashes. By the way, this I want to reiterate. This is not a reverse. This is not a reverse engineered clone of anything Microsoft wrote. This is actually the real deal ported to run on these operating systems. This is not some crappy half-rate RE junk. It's really it's the real deal. Anyways, I think we're gonna have to give up on that VAX PATHWORKS server, but oh man, I want to find some way to access it. You know what? I have just the solution. Stand by one moment for a jump cut while we switch from virtual to real, and I will see you on the other side. Alright, well let's rock on with XP. And not XP, we're actually going to rock on with Wireshark. So we're going to go ahead and view packets of the browser persuasion. You know, this is going to take 20 years to go through here while we filter for our browser packets. But what the browser protocol does is basically the replacement to the SMB mail slot. Well, okay. Not really. The browser protocol became more sophisticated later with LLM and R, which, okay, I know that's not browser, but it sort of does the same function more or less. I know that's a weird comparison to make, to compare SMB to anything that's not SMB, but yeah, we're going to look at this, and if this would hurry up and filter, you know, we have a zillion packets from all those X11 packets. Hey, you'll see it here in a second. There we go. Holy smokeola. Alright, so we have a ton. Got a ton of junk. Okay, this right here is... Alright, we'll just start at the top. So, host announcement domain. This right is a domain controller. I call it domain. I'm sorry if you don't like it. I don't like it either. But this is spitting out, and it is a workstation server, domain controller, time source, dial-in server, NT workstation, and DFS server. This is a server 2008 R2. We have a UNixWare 714. This is exactly what this sounds like. You know what? Let's actually look at that machine. It's actually exactly what it sounds like. It's literally a UNixWare. You know, we have PATHWORKS. Well, we also have a UNixWare system. Why do I keep clicking that? Entire network, Microsoft Windows network, UNixWare 7 domain. You know, this is why Windows has a bad reputation. This right here is a, yeah, okay, sure it does. Okay. You have 7 domain. This one has 1, 2, 3 for the password, I think. This is an SCO UNixWare. Oh, well, okay, it's not really SCO, but, you know, it's Unix System 5 Release 5. This is bizarre. What is my password? Well, you know what? We'll fix it. As always. Oh, that's right. Oh, yeah, that's right. Net user. Okay, now we can sign on. Okay. We'll go ahead and mount this one as a network drive. Notice the exact same shared folder layout as the other machine we were looking at earlier, the PATHWORKS machines, and that's because they're the exact same thing. And lo and behold, it also pretends to be NTFS. So, to put it in brief summary, SCO Advanced Server for UNixWare 7 is the same code base as DEC/Compact PATHWORKS 6.1 for VMS. PATHWORKS 6.1 for OSF1 is much newer, it seems. It's kind of odd. Okay, so that's that machine. So we'll switch back over to Wireshark so we can see what's going on here. So there's some browser packets for that. Here's an OS2 machine, which of course identifies as, rather than an NT workstation and NT server and domain controller, it just identifies as workstation server and domain controller. So this is running on an older version of the LAN manager software. Here's a domain and or workgroup announcement. And keep in mind, there's a difference here. There are different browser announcement types. A local master is basically a primary server in a domain, or what we would call the master browser, which means a primary domain controller, sort of, in Windows NT terminology. Because in Windows NT you have a primary domain controller, and you have backup domain controller, and then you just have standalone servers. This right here is a standalone server. It's a host. But a local browser and a local master browser refers to this. And when I say browser, I mean it's like a noun, not like the verb to browser pack. What am I saying? Anyways, there's a difference. It's just a weird way of explaining it. Okay, so here's an OSF domain, which is being shot out to this DEC NetBIOS emulation address, which, no, this is the NetBIOS broadcast address. You see, these are all going to the special NetBIOS broadcast address. And this is identifying as two things. It's also identifying it as a domain controller and a Xenix server, and also a domain enumerator. Then we get the local announcement, or the local master announcement for this domain, and this being the domain controller. So it's a workstation server, domain controller, Xenix server, NT workstation, master browser, domain master browser, and OSF. That's right. What do you know? It actually has the elusive OSF flag set, which is apparently like the rarest thing since a hen's tooth. And if we look at the server type, you'll see that this is a OSF server. And it's also a XENIX server. It's not a domain controller, is it? Yeah, no, yes. Domain controller, yep. Okay. Let's see what else we got. WinFrame. This is a Citrix ICA server. This is a remote desktop protocol, which is something I'll look at in the far future. This right here is a workstation. It's a server. It's a NT workstation. It's an NT server. It's a potential browser, but it's not a master browser. Yes, it is a master browser. Okay. And it's not a DFS server, but it has unknown server type 28. Unknown server type 28 is the field bit that Wireshark does not understand for a Citrix ICA server. If we come down here and look at, okay, so this WinFrame machine just has ICA. ICA is like the precursor to RDP. It ended up being concurrent with RDP. But I also have a machine, NT4Term, that has both RDP and ICA. So of course server type 28 is ICA. Server type 25 is RDP, aka terminal services. And this is pretty much the same thing, except this is a backup browser rather than a master browser. So this would be considered just a host in a domain, if that makes any sense. And you can see this coming out over multiple protocols. Here's our VAX VMS machine. This is a workstation server, domain controller, time source, print queue server, XENIX server. Yeah, right. NT workstation and VMS. And if we come down here, this is a VMS host. Another rare flag checked off. NT4 ENT serve. This one right here has Microsoft SQL Server installed, and it also has Apple Share services. So it has the Apple Share bit set. This one right here, okay, this one's a monster. This is a Windows 2000 domain controller. So this has more flags than anything I've ever seen. So we better just read them off of this. So it's a workstation server, domain controller, time source, Apple Share server, has a print server, it has dial-in capability, which means it's running routing and remote access. It's an NT workstation. It's not Windows for workgroups. It is a master browser. And it also has unknown, well, I'm going to tell you it's going to be unknown server type 25, and that is for terminal services. This right here is server 1. This is actually a Samba server, because you can tell because it's a DFS server and XENIX server. So if you're trying to pinpoint what operating system something is that's running on your network, and you don't really know what it is, you can bisect it based on all these examples I'm hopefully giving you. So if you get XENIX server and DFS server, it's Samba. And if it's domain controller in there as well, then it's also a domain controller running on Samba. Okay, so OS2. This is exactly the same thing you're going to see from like a standard, like a DOS LAN manager domain controller. It's just going to be workstation server and domain controller and time source. And that's because OS2 runs basically the DOS version of LAN manager. Okay, we've seen those. NT4 server. This one's pretty basic, except there's a different, or there's like a difference. So this is the this is also a backup browser on IP because it's aware that there's other domains, but within this IPX network number there are no other domain controllers. So that's why it's doing this. Here's a domain announcement for a work group, and this right here is what allows older clients, like older OS2 and older DOS LAN manager clients, and I guess Windows for workgroups as well, to browse NT domains. Is this flag right there. Okay, and then some of these others are pretty average, and here we go. Here's my actual workstation. So just a Windows 10 desktop is workstation server, NT workstation, potential browser, and then the host name. And some of these, here we go. Here's the UnixWare machine that we saw before, rebeaconing. So there's all these different flags that can beacon. So if you're just trying to figure out what's on your network, and for whatever reason you have a bunch of old junk running, here you go. Now, this right here is another Samba, except this right here is a beefed up Samba machine. This one has a lot of stuff on it, and it is a workstation server, print queue server, XENIX server, NT workstation, NT server, master browser, and DFS server. So again, XENIX DFS is generally the catch-all for detecting Samba. If you don't know what DFS is, it's distributed file services. But I think that's going to go ahead and cut it for here. I think I've pretty much covered everything I wanted to cover within a timely fashion, and I know that this is kind of a complex video, and I really covered a lot of ground, and I went between a lot of machines, and even unfortunately had to see me, or I don't know, maybe fortunately, who knows. But I think that's going to go ahead and wrap it for this one. Thank you for tuning in. This has been a production of the HS Tech Channel. If you have any questions or suggestions for future videos or any comments, please do let me know, and I'll see y'all in the next video. Goodbye.